All right, let's talk chatbots. You've probably noticed they've gotten, well, a lot smarter. But have you ever stopped to wonder how they went from those clunky scripted responses to actually generating new, fluid, human-like text? Today, we're going to pull back the curtain on the deep learning magic that makes it all happen. So that really brings us to the big question for today's explainer, right? How in the world do these modern chatbots actually learn to talk like us? How do they get beyond just repeating pre-written scripts and start, actually conversing?
Yeah, I totally remember the old chatbots. It felt like talking to one of those automated phone menus. You'd say billing, and it would just spit out the same pre-programmed billing response every single time. But the bots we see today, they feel completely different. So what was the big change? What's the fundamental shift that happened here?
You hit the nail on the head. The fundamental shift, and you can see it right here, is moving away from that rigid rule-based logic to a deep learning approach. So instead of programmers sitting there writing endless "if the user says this, then reply with that" rules, we now just feed a model millions of real conversations. It literally learns the patterns of language all on its own. The huge difference here is that it's not programmed, it's trained. That's what allows it to be so dynamic and to generate completely new sentences. Okay, that makes sense. So deep learning is the secret sauce here. But what is that really? What's the actual mechanism that lets a machine learn from all that conversational data you mentioned? Well, at its core, deep learning uses something called neural networks. And these are basically algorithms that are kind of inspired by the way neurons are connected in our own brains. The best way to think of them is as incredibly powerful pattern recognition machines. So when you show a neural network, say, millions and millions of examples of questions and their answers, it just starts to figure out all the super complex relationships between words and phrases and ideas all by itself. No human has to go in and hard code the rules of grammar. It just learns. Okay, so we've got these powerful pattern-finding networks. That's the engine. But is there a specific blueprint for this kind of task? An architecture designed specifically for taking in a question and then generating a brand new, unique answer? There is, and it's a really elegant concept called the sequence-to-sequence model, or just seek-to-seek for short. As you see here, it uses two special kinds of neural networks called recurrent neural networks, or RNNs. Now, all you need to know about RNNs is that they're built specifically to understand sequences, like the order of words in a sentence. The model uses one RNN as an encoder and another as a decoder. And honestly, the easiest way to wrap your head around it is to just think of a human translator. Let's stick with that translator idea. So first, the encoder part. It reads the input sentence, like, "How are you?" to really understand its meaning. Then, and this is the cool part, it compresses that meaning down into a string of numbers. We call this a context vector. Think of it like the core thought or idea the translator holds in their mind before they start speaking. Finally, the decoder takes that numerical thought and basically translates it back into language, building the answer one word at a time to generate, "I am fine." And that right there is the absolute key to the whole thing. That fixed size feature vector you see mentioned, that is the context vector. It's the distilled essence of the question. It captures all the important information so the machine has something concrete to work with. This is really why we can say the model understands the meaning, not just a random string of words. Okay, conceptually, that makes total sense. But I'm kind of stuck on a practical detail. We're talking about feeding the model words and sentences, but neural networks are all math, right? They need numbers, not text. So how do we bridge that gap? How do we get from a raw sentence someone types to the numerical data the model can actually understand and use? That is such a critical question, and you're spot on. To solve that problem, all the raw text has to go through this really rigorous data preparation pipeline. You can think of it like an assembly line that takes messy human language and turns it into the structured, numerical format that the model needs to work. So here's how that assembly line works. First up is cleaning. This is just standardizing the text, removing punctuation, expanding contractions like it's into it is. Step 2 is tokenization. This is where we break each sentence down into a list of individual words, or tokens. And finally, step 3 is padding. Since the model needs every input to be the exact same length, we add special pad tokens to the shorter sentences to make them all match. It's all about creating that uniform, predictable input. Wow, okay, that's a lot of different pieces that have to work together perfectly. To make sure I've got it, could you just give a quick recap of the main ingredients that make all this text generation possible? For sure. It really boils down to these three key components working in perfect harmony. First, you've got deep learning. That's the engine, the part that learns all the patterns from conversational data. Second, there's the seek-to-seek model. That's the architecture, the blueprint, that knows how to translate a question into an answer. And third, you have data preparation. That's the absolutely essential process that turns our messy human language into the clean, numerical format that the engine can actually use. And when you put those three ingredients together, you get a system that doesn't just look up information, it actually generates new language. It's a technology that is just evolving at an incredible pace. And it kind of leaves us with this huge, fascinating question to think about. As these machines get better and better at the art of conversation, what does that tell us about our own intelligence? What does it truly mean to be human? Hey, if you enjoyed this explainer and found it helpful, do us a favor and hit that like button, share it with anyone else who's curious about this stuff, and of course, subscribe for more deep dives into the tech that's shaping our world. Thanks so much for watching.